Hi everyone, we're going to do a quick introduction for lesson 3.2, polynomial functions and their graphs. So we're going to start out by looking at some terms that you probably should know, but I wanted to make sure that you do. The first one is standard form for a polynomial. In any given polynomial function, standard form means that the powers on the variables go from greatest to least. So to change this into standard form, this 6x cubed needs to come first, and it's going to keep the sign that's directly in front. Because this is a plus sign, I know it's positive. If it had been a minus sign, I would put a negative sign right here. Then this x squared would be next. Now it's positive, so I'm going to do plus. Then the minus 5x, and then the plus 10. So this is in standard form. Okay, because it goes greatest to least. Then the leading coefficient is the number multiplied by the variable on the first term. So this is your leading coefficient because it is the first number that shows up at the very beginning of the polynomial. And even if there isn't a number, like hypothetically speaking, if this was in standard form, there's no number here, but that number is 1. Remember the invisible 1 that's attached to each variable? So hypothetically speaking, if this wasn't here, and this was in standard form, which it now is, okay, the leading coefficient would be the 1 that's attached to this x squared. So there's always a leading coefficient, and it's the number that's attached to the first variable that shows up when it's in standard form. Now the leading term, again, needs to be in standard form, and this is my leading term. Okay, because it's the first term of the polynomial. Now each of these terms is a monomial, so a plain number can be considered a monomial. It can be a number times a variable. It can just be a plain variable. Okay, those are all different forms of monomials. Separately, they are monomials. When you put them together, they're polynomials. Remember what that prefix means. Mono means one, poly means multiple. Okay, now finally, continuous. Continuous describes a graph. If a graph is made up of a continuous curve like this, we call it continuous. If a graph has a break in it like this, maybe it goes from here and then there's an open circle and it continues on from there, this is not continuous or discontinuous. Another way you might have a discontinuous graph is if there's a hole in it. And we're going to talk about holes in lesson 3.7, but there might be a hole in your graph and that would make it discontinuous. So continuous means it's one smooth curve like this. It can be any shape as long as it's smooth, and it doesn't have, that's a cusp like that. It doesn't have a cusp in it. It doesn't have a corner like an absolute value function would have, and it doesn't have any holes or breaks in it. This is continuous. The rest of these are not. Now, let's talk about how to graph a polynomial. I put 5 steps on the board here. It says find the zeros and the y-intercept. You always start there. Then you plot the x and y intercepts, okay, which is what you found in step 1. Then you're going to make a table of values to get more points. Finally, you're going to look at end behavior, which is something we're going to talk about in class. And then we're going to just connect all these points. So this is my first function I'm going to be graphing. Notice they factored it for us, so it's much easier to find the zeros. Okay, so the first 0 would be this is -2. The next 0 would be right here at +1, and the last 0 would be right here at 3. So I have -2, +1, and 3. Those are my 3 zeros. So those are the zeros. Now I need the y-intercept. Now, the y-intercept is much easier to see if this was multiplied out. Now, it's going to be created by multiplying 2 times -1 times -3. So if they give it to you in factored form, you can just multiply all of the plain numbers together, and that will get you the y-intercept. So 2 times -1 times -3 is positive 6. So my y-intercept is 6. So I've now done steps 1 and step 2. I found the zeros and put them on the graph, and I found the y-intercepts and I put them on the graph. Now I can make a table of values to get more points. Now when you do that, the goal is to find points in between these zeros, and you can, if you have at least one, you're okay. So like in this one, I don't necessarily have to find a point on this -1 line. If I do, it will actually make my graph better. And I should find one that's in between these 2 points. So on my trusty graphing calculator, there's an easy way to do it. Let's hope that you guys can see it clearly. If I go to my y=, menu, no, you can't see the screen. I'm so sorry. It's because the brightness is turned up a little too much. Let's see if I can fix that. Let's see. Okay, I think that might be a little better. But all I'm going to do is I'm going to type in my function, so parentheses x, yeah, you can't see it, plus 2, parentheses x minus 1, and parentheses x minus 3. Okay, I'm going to quit the y= menu, so second and quit. And then I'm going to evaluate this function for any values I want. So if I want -1, I'm going to hit alpha, trace, and it brings up a menu, and I know you can't really see it, but right here it says 1, y1. So I'm going to hit enter, and then parentheses -1, parentheses, because that's the value I wanted to put in. And I hit enter, and I get 8. So if I put in a -1, I'm going to get 8 up here. So that's right there. Okay, and now I also want to put in +2 because that'll get me a point in between these two. You can select any value you want. I hit second enter to get the previous entry, and now I'm just going to replace my -1 with a +2. So I got -4. And again, I'm very sorry you can't see that on there, but that's what I did. At least you could see what buttons I was pressing. Okay, so I got a table of values. I found out that when x is -1, then y is 8. And I found out that when x is 2, y is -4. Okay, and you can get as many points as you want. These ones are sufficient for me. Now, as far as end behavior goes, it's based on the leading coefficient of your polynomial. Now, this is not multiplied out. If it was multiplied out, the leading coefficient would be defined by x times x times x. It's all the variable terms multiplied together. So the leading coefficient is x cubed. Now, this is positive, and the power is odd. Positive means that it's going to point upward on the right side. Odd means that it's going to point the opposite direction on the left side. Okay? So now all I have to do is connect all of this into one big graph. So I'm going to go downward to there, and you just do your best to kind of get it to look a little bit like a graph. So that's it. Again, more points would make it better. I don't have more points. But you could get more points if you wanted to. Let's look at one more function just to make sure you understand what's going on. This one, they didn't actually give me the factored form, so I have to factor first in order to find those zeros. So the function I'm given is p of x equals x cubed minus 2x squared and minus 3x. Okay? So first I'm going to find the zeros using factoring. So if I was to factor this thing, I would factor out the x. And then I would factor this using looking for numbers that multiply to -3 and add to -2. So that's going to be x times x minus 3, x plus 2. Sorry, plus 1. Okay, because -3 times +1 is -3, and -3 plus 1 is -2. So this is my factored form. So my zeros are 0, 3, and -1. So let's put those on here. Here's 0, 3, and -1. Those are my zeros. Okay, now notice this point here is also the y-intercept because it's on the y-axis. So I've done steps 1 and 2. Now I'll make a table of values. And again, I can put it in here or I can use my graphing calculator. I should find something in between these 2 points. So I'm going to do -1/2. And I should do something in between these 2 points. I can do either +1 or +2 or both of them. And since with my graphing calculator it's easy to do both, I'm just going to do both. So in my graphing calculator, again, I know you can't really see the screen, but in my y = menu, I'm going to type in my function, and I'm going to go back to the original function, x cubed minus 2x squared minus 3x. Then I'm going to quit, so second end mode will quit. I press alpha trace, and I select number 1, y1, because that's where I put my function. Now I just put parentheses, and I can type whatever number I want. So I want -1/2. So I did -0.5, and I hit enter, and I got 0.875. Okay, now I want +1, so I'm just going to hit second enter to get that last entry. And I'm going to put 1. And I get 1 is -4. And then second enter again. And I'm going to put a 2. And I got -6. Okay, so I'm going to graph these points. They'll give me a better idea of what's going on. -1/2, I got 0.875, which is a little less than 1. +1, I got -4. +2, I got -6. Okay, now the last thing I need to do is determine the end behavior, and that's done by the leading coefficient. This is positive, meaning it points up on the right, and it's odd, meaning that it's going to point in the opposite direction on the left. Now I'll just connect all my points. There we go. And this is an arrow, and this is an arrow, and that's my graph. Okay, and again, you can get more points to get a better idea of what this graph is doing, but you don't have to. So that's it for this video. I hope that was helpful, and let me know if you have any questions.